Hello and welcome to the first episode in a series of small video tutorials for how to use the Lux programming language. I am Eduardo Julian. I am the creator of the language, and I'm gonna be showing you how to use it, how to compile Lux programs, what everything means, the different tools that the language provides, and even some libraries I'm building that hopefully will be available to everybody in the future. So right now I'm gonna be showcasing Lux version 0.3.3. It is the latest stable version of the language. It is almost feature complete, and you can get it from the repo by just downloading the compiler from the list of releases. It will be the Lux CJAR. You're gonna need it. In this particular video, we're gonna start with a small project. I have already set up everything you need. For the project, you will need just a source folder with all your files. The test can be omitted for now. A project file, which is what you use for building the project, and the compiler itself. So before I go into the details, technical details of how everything works and how you can use it, I will start by talking about what Lux is. So Lux is a functional and statically typed programming language in the Lisp family of programming languages. So I'm gonna be a little bit. I'm gonna provide some simple explanations for some of the concepts that I'm gonna be discussing. And one of the reasons is that this video is not only destined for people in the budding Lux community who want to learn Lux, but also for my coworkers back at work who are not familiar with Lisp, who are not familiar with functional programming, who are not familiar with a lot of the ideas that make Lux what it is. So this is gonna be a very simple series of videos. So I'm gonna explain everything from the ground up. Nothing will be missed or dismissed. So hopefully, even for more experienced programmers who know some Lisp and who know some functional programming but aren't necessarily familiar with all of the ideas in Lux, it's gonna be a gentle introduction to everything that Lux has got to offer. So being a functional programming language entails a variety of things for Lux. One is that functions are the main mechanism for abstraction in Lux. Yes, you can use objects because Lux compiles down to JVM bytecode, so you have access to all the objects that the Java Virtual Machine provides, but they are meant to be used for interfacing with the platform, not for day-to-day programming. For common programming, functions and abstractions based on functions are going to be your main tool for building your programs. For some of you who might be more familiar with object-oriented programming, that might sound very intimidating because you might think, but how can I do anything at all with these functions? I mean, I structure my programs with objects and classes, and they are much more complicated than functions. But in reality, just functions are enough because you can use functions and functional composition of different kinds to create elements of arbitrary levels of complexity in very simple ways, instead of having to do everything in a very ad hoc manner as object-oriented programming tends to be. So Lux is also a statically typed programming language, but it is perhaps different from what a lot of people might be familiar when they think of statically typed programming languages, because everybody thinks of something like Java or C# or something like that has very rigid and somewhat limited types. The Lux type system is actually very flexible. It features type inference, which makes it much more easier to use because you can avoid writing types in many circumstances, because the type system can just figure out what is that you need based on what you have written. And another interesting difference is that most languages with static types have nominal static types, which basically means that two types differ because of the way they are named. If they have the same name, they are the same type. If they have different names, they are different types, even if they contain the same data in the same order. So nominal type systems don't care about the shape of your data, they only care about the name. The Lux type system, on the other hand, is a structural type system. All that matters is the structure of the type, what it contains, and in which order. So you can have two completely separate types defined into completely separate modules, and if the structure is the same, there, if you give one instance to the type of one of the types to a function that takes an instance of the other type, the function is actually going to type check, because as far as the compiler is concerned, they are the same type, because they have the same structure, they have the same elements, they have the same everything. Now, the details of how the type system works is something that we're going to be exploring in future videos, because right now this is going to be just an introductory video. And finally, the third aspect that makes Lux what it is that it is a language in the Lisp family of programming languages. Now, there are many different families of programming languages that share certain traits with each other. Be it maybe that they have similar syntax, or that they have similar semantic elements, or maybe that they have a similar philosophy as to how to make software. Now, I'm not gonna go into detail right now as to what is maybe the essence of Lisp, because I want to explore that more on a piecemeal manner as we go into Lux, so that you can see the different aspects of Lisp in practice, having an impact on your programs, which is much more important than just giving you a list of features right now and hoping that you will understand. So I'm just gonna mention one particular characteristic of Lisp, which is the one that you're gonna be noticing much more obviously right now, and that is the syntax. As you can see, everything in Lux tends to involve parentheses. So here we have this import thing here that has a bunch of parentheses and a bunch of names, and then we have this program thing here that also has a bunch of names. It has a string here, it has this thing with brackets, and other than that, several parentheses. Now, Lisps tend to define expressions, which are things that produce some kind of value or make some kind of calculation. And the way they define expressions is by combining things like names or identifiers or symbols, or however you want to call it, and values like numbers or booleans or strings or something like that, and they delimit those expressions using parentheses. So by using parentheses, you always know what expression contains, what is its shape, and what are the limitations of the expressions. Where does it start? Where does it end? Where is it inside another expression, or is it at the top level? That kind of stuff. The brackets delimit a separate kind of expression that is called a tuple, and there is another kind of delimiter, which are the braces that delimit records. But we're gonna see those things in tomorrow's episode, in which we're gonna talk about the primitive data types, and we're gonna talk about functions and that kind of stuff. For now, we're just gonna be examining this little program. But first, I think we should compile it down and run it to see, what does it look like to compile down and run a Lux program. But first, we should see how to build the program itself. So you can use a compiler to compile your programs, but most cases it's not gonna be that convenient, because at some point you will want to use some libraries somewhere, you want to use some dependencies, and just a standard library is something that you already have to pull in as a dependency, so that's important. So the Lux right now uses the Lineagen build tool for building its programs. So Lineagen is a build tool that was originally designed for the Clojure programming language, but since Lux is a fairly young programming language, I couldn't afford to just sit down and make a build tool right at the start, because I don't have the time to focus on that right now. So instead, I just made a plugin for Lineagen, which is this one here, the Line Lux C plugin. Right now, the latest stable version is 0.2.0, and you can get it pretty easily. So besides that, we're also going to be using the Lux standard library as one of the dependencies of our program. The latest stable version is 0.3.3. We're also specifying the line lookc plugin that the name of our program is just program, and that is the case because the file that we're going to be compiling is named program.looks. So depending on the name of the file, we will have had a different parameter here. And finally, here in the source path, we're specifying that we're going to be using the source directory for hosting all of our files. And it could be anything. By default, Lanagen actually uses a directory named src, but I prefer the longer name, so I'm using source. So now we know what we need for build 2. Let's build the program. So here I have a command line, and I'm just gonna run line lookc compile, and our program is gonna begin compilation. So you're gonna see every single definition that is being compiled. I'm gonna explain tomorrow what definitions are and what they contain. They're not just values and functions. They can contain some interesting data besides that. And right now it's compiling a variety of modules because our program module itself uses a variety of modules themselves for all the things that it needs. And as soon as it is done with all of those modules, now we have compilation done. So let's just wait until the build tool is finished. Now we've got it. So after the compilation, the compiler is going to generate this directory here, target. Inside target there is JVM. The reason is that Loox is meant to target multiple platforms in the future, so right now I'm just dividing the output of the compilers depending on the platform. And in here we can find the classes that were generated for all of the things that got compiled down during the process, and an executable jar that contains the program itself. So let's run it. We're gonna do java -jar target jvm program.jar, run it, and we got our message, hello world. So let's see. Okay, so now we know more or less what Loox is and how to compile things down. Let's do some simple explanations for, what do we have here in this program module. So a module in Loox is simply a file that contains Loox code. In this particular case, we have the program.loox file, so we have the program module. So in the import statement, we are importing a variety of other modules which contain functions, macros, types, and a variety of things that we're going to be using for our program right now. And we have a definition of the program itself. So here in the program itself, we have args, which is just a list of text elements that are the inputs to our program. Right, so right now here when I run this program, I ran it without any kind of inputs. I just ran it, and those inputs will have gone, if I had given it any inputs, they will have gone to the args variable. Right now we don't have it, but later on I'm gonna show you how to take those inputs and maybe use them. And this thing here, this do IO monad thing here and the wrap thing, I'm not gonna explain it not right now because I'm gonna talk more about monads in a future video. But suffice it to say that right now this is going to be a little bit of ceremony for getting us to print hello world. Later on you're gonna understand why monads in general are so important and so useful, and why it matters to have them here. So right now the only thing we care about is to log the hello world string. Log is a function that just takes a string and prints something to a standard output. So it's kind of like print line in other programming languages, and we can just print what we want here. Now let's say that instead of just doing this, I would like to print something that I got from the arguments, right? Maybe I don't want to print world. Maybe I want to print um, something like the name of somebody, right? So let's say that instead of doing this, we're gonna do something like let's say that instead we did something like this. But by the way, I think this is a great opportunity to say that when you compile Lux programs, you don't need to compile everything from scratch. The compiler actually caches what the results of previous compilations, such that if you make a change in one file, you don't have to compile everything to get your new program. Instead, you just compile the things that you need, which is why this run of the compiler, it was actually pretty fast. We only changed this program. We didn't change anything that we depended on, so there was no need uh, to do much extra work. So this will print hello world. This will print hello Eduardo. Hey, we've got it. So what exactly did I do here? Well, this is what is called pattern matching, which is one of the main tools that functional programmers use for working with data. Basically, it allows you to check what is the shape of a particular item of data, and you can extract data from that shape and use it for different purposes. Now, in particular, I'm saying, hey, if the list that I am getting, the list of arguments, if it is empty, then just give me hello world. Nil is the way of saying that the list is empty. We're gonna talk more about lists and the funny names that they have in future episodes. And cons is a way of saying, hey, this here, if the list has at least one element, which I'm gonna call name, I just want you to concatenate these two things, hello and the name. Now I had to import the concatenation operator, and the way I did it was a little bit different from what you have seen so far in the import statement. I'm not gonna go into a lot of detail as to why that is and how it works, because I will leave that for future episodes. But suffice it to say that I just got myself a list concatenation function. I gave it the text prefix, but it doesn't have to be that way. I could have instead just not have any prefix, and it will have compiled and worked just the same. I get the concatenation operator from the monoid, and well, I'm using a function application. I'm using pattern matching to get the string that I need to print to standard output. So for now, again, I'm not gonna go very much into detail as to how everything works, because I will leave that for future videos. This is just meant to be an introductory video. But as you can see, it is possible to compile Lux programs. It is efficient to compile Lux programs. You can pull in libraries from anywhere. You can do pattern matching on values. You can print the standard output. You can do a variety of operations. Later on, we're gonna see how everything works and how everything fits together. And finally, I want to talk about where can you get Lux documentation if you want to learn more about Lux on your free time and outside of this series of videos. So the first place to look for information on Lux is just the repo, the Lux lang Lux repo. So the main place in here is the wiki, and especially the standard library. Well, you're gonna be using this a lot as you write Lux programs. And the beautiful thing about this documentation is that I don't write myself. I actually made a program that generates this documentation in here from the source code of the standard library, which means that this will always be up to date. It will always contain information on everything the standard library provides. It has a bunch of documentation, explanations, examples of usage, all kinds of stuff. So for those of you who are gonna be writing Lux code in the future and maybe playing around with this programming language, this here is a great resource to figure out what the standard library provides, how to use it, and how to explore Lux by yourself instead of just having to rely on this series of videos. There's also the Trello board for Lux. This here allows you to see, how progress is being done on the language as I work on new features for upcoming releases. Right now I'm working on the 0.4.0 release, which is going to feature a variety of optimizations to the compiler for generating better code, for making the compiler itself faster, a variety of new features, bug fixes, improvements, that kind of stuff. If you want to get the link, all you need to do is look it up somewhere on this page, right here in the end. And finally, there is the Lux devlog. As you can see, here's the URL. And in here, this is more about, me talking about how I am developing Lux, the kinds of ideas that I'm coming up with, how I'm implementing certain things. It is mostly written from the perspective of a compiler implementer and a language designer. So if you want to understand maybe the logic and the rationale behind why Lux is the way it is a great resource. There are a variety of posts covering a variety of subjects. I don't update this regularly because I tend to wait until I have big